Good morning. This is Tim Stewart. I am president at Visual Decisions, and we are here today to talk about how to modernize operational excellence. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. So with that, let's go ahead and get into the presentation. So first of all, I'm going to talk about Operations 4.0 and what I mean by that, and then why add Industry 4.0 solutions to very well-established lean practices. What I'm going to start off with is what is Industry 4.0. And if you see this very small print diagram over here on the right side, that is from the World Economic Forum, where they define many of the technologies that are part of what is considered Industry 4.0. For my purposes today, I'm really going to focus on just a particular segment of that and looking at 4 technologies in particular: advanced analytics, the industrial Internet of Things, machine learning and AI, and then augmented reality. One thing I will say right up front is that the technology enough is not alone, or the technology alone is not enough. A Fitbit is a great example of an IoT device, and I talk about it all the time in my webinars, but I've been wearing a Fitbit for nearly 9 years now, and I've gained weight during that time, and it's really not the Fitbit's fault. Fitbit works great. Almost all of these IoT devices and software applications and so forth actually do exactly what they say they're going to do. In the case of the Fitbit, it has a lot of advanced sensors that you wear on your wrist, sends that information to the cloud, employs machine learning and artificial intelligence to interpret that information, turn it into footsteps and heartbeats and so forth. Presents that information through nice analytics on the web, on your phone, etc. And I haven't lost any weight because I've been basically ignoring it. I haven't changed my behaviors. I haven't exercised more, etc. And so therefore, it hasn't achieved the gains I was looking for by purchasing one. But it's the same thing on the shop floor. If you make investments in these IoT devices and so forth, you have to change the culture of the organization. You have to change the standard work, the behaviors of your people to take advantage of these new capabilities in order to really make a difference. And that's why what we talk about at Visual Decisions is combining that smart factory with the lean factory in order to drive those improvements to your organization. But it's not just us talking about that. Here's a study from Bain and Company looking at traditional lean systems and the improvements that you can get from going lean. And then if you look at digital lean, how much more you can actually save with the combination of those 2 different technologies. So now, what is it exactly that I mean by talking about Operations 4.0 or smart and lean, etc.? And I'll start off by saying that manufacturing has really embraced technology and automation, but continuous improvement teams, by and large, have not. And so when you look at manufacturing, you see all kinds of different technologies out there: lasers, robots, cobots, all kinds of different things that manufacturing has really embraced over the past 20 years or so. Continuous improvement is largely still done on paper, on whiteboards, sticky notes on walls, things like that. And so I think that there's a tremendous opportunity to update how we do continuous improvement to take advantage of some of these new capabilities. And to do that, we need to look at both the management system that comes along with Lean, as well as the actual toolkit that we put in place. And so, over the course of the past year, I've had webinars on pretty much all of these different topics. Be happy to walk through those with anybody that is interested. But things like standard work for leaders, visual controls, making Gemba more effective, management operating system, Kaizen, root cause analysis, value stream mapping, all of those different things can be improved significantly with technology. You just have to change the way that you go about it. So we'll talk about those at an overview level today, as well as a few other topics. So, let's start with the basic, standard work. How do digital Lean solutions help standard work? Well, I'll give an example in a minute, but essentially we're delivering the right information to the right place at the right time to the right people, and in the format that they need it in order to take action. And then, we can help, augment the people in our organization with new capabilities to create new types of standard work that can be performed. We encourage the adoption of new and standardized work practices. And perhaps most importantly, we can detect and elevate attention to the deviations from those work standards, so that when people go off script, we can see that immediately and take whatever action is required. But conversely, standard work actually helps Industry 4.0 quite a bit also. As I said, Industry 4.0 solutions won't provide a ton of value until the behaviors change. And so how do you get the behaviors to change? Well, you create the standard work around that. And so it helps drive adoption of those new solutions, provides a lot of the inputs, such as reason codes for downtime. I mean, you can grab some of those from the machine itself, but there are times when the machine doesn't know what's happening, and you need that input from a person to say what actually happened. And then the use of the systems by leaders helps to validate that data and drive that usage within the organization. So one example of merging standard work with these different technologies can be done through work instructions or connected work cell and so forth. And so, what we can see, as we are at our workstation are those detailed work instructions. They can be done on the computer. You can do it through, the glasses for augmented reality, so that they don't have to, divert their attention from the work process itself. They can see that right in context. But you can also do all kinds of different things in terms of stepping through those work instructions, gathering information, having that be part of that overall workflow and so forth, and build SPC and so forth right into this whole process, so that everything is integrated together for that operator, and you're giving them as much assistance as you possibly can to do the work the right way, the first time, and capture, the additional information and really enrich that entire process. From a visual control perspective, certainly there's opportunity for these to be modernized as well. This is a typical, SQDCM board within manufacturing, looking at safety, quality, cost, delivery, manpower. You can throw in, inventory and environmental and so forth in there as well. But basically, your basic categories of KPIs that manufacturers look at out on the shop floor. And this is a very typical way that those boards are maintained today, which is great. You get the involvement of the people putting the information up there and so forth. But there's a lot of disadvantages. You can't drill into these reports. They're only as up to date as somebody going out there and writing on them with a marker or printing them off from Excel and posting them up there and so forth. If you have conversations around the data that's up there, there's nothing else that you can drill into to find additional information. You have to go someplace else. And so while these are great, there's a lot of potential upgrades. And so when we think about these manual visual controls, there's a great book, love the book, Creating a Lean Culture by David Mann. Highly recommend it. But to me, it feels a little bit dated in one area around visual controls. As he goes through there, he looks at different attributes of visual controls that are still very relevant. Is the information timely? Is it accessible? Is it precise? Is it verifiably accurate? Does it prompt questions? Is it easy to change and customize, etc.? And as he went through this, he kind of contrasted what he said is manually controlled, if the people are putting that information in there, versus IT provided. And the IT provided is really based on, old school ERP system reporting that is extremely inflexible. You have a 9-month wait from IT for any change, etc. With new school industry 4.0 solutions, I don't think his analysis is accurate anymore. And as much as I have respect for him, the work he's done, the book he provides, and so forth, when I look at each of these different questions from an industry 4.0 perspective, the solutions that can be put on the floor today really just blow away both the manually controlled and the IT provided for all of these questions, except perhaps the easy to change and customize. It's hard to beat paper forms in terms of how easily you can change those. But everything else in terms of, is the information timely? Is it accessible? Is it precise? Is it verifiably accurate? Does it prompt questions? Is there kind of an intimidation factor that goes along with it? Ownership or alienation, et cetera. All of these things can be significantly enhanced through Industry 4.0. Now, when he says that IT provided systems can be very intimidating to those not literate in the system, that again was probably true with SAP back in the year 2002 when the book was written. But everybody uses a smartphone today. Everybody has access to computers and everything else. And having information on a screen is not any more intimidating than it is writing it by hand on paper. And really, having to do the math to make those things accurate on paper is probably more intimidating than it is to be able to interpret that information off of a screen. Now, this is kind of a summary of the arguments that I've heard from various people in continuous improvement in terms of being able to maintain fingerprints on the process and that ownership that comes along with people having to write that information down, putting your pieces produced on the pasteboard every half hour, every hour, et cetera. And for each one of these, I think that the answer is not just how does the information get into the system and displayed, which is all that we're really doing with the manual system, but also how do you use it? So if you can save the time of people having to walk over to a centralized whiteboard to write the pieces produced on a pasteboard, or post up their SQDCM metrics and so forth, how can you utilize that time more effectively? And the answer is, well, you can keep the people at their work cell and display the information within each work cell and have the people actually use that information to improve the process. You can provide much richer context information so that they can deepen their understanding of what is happening and really enrich that whole process and get them more invested in the change and using that information to make things better, as opposed to simply recording what's happening. Now, none of this means that Gemba should stop. You should always, have a significant portion of your day going to where the work happens. Management from the plant manager, all the way down, still need to go out and observe the process. But as they do so, they can carry a tablet with them that shows them not just what's happening right at that second at the work cell, but they can have a conversation with the operators, the supervisors, et cetera, about everything that's happened during that shift, during that day, over the course of the week, et cetera, and have all of that information at their fingertips. And so it makes that Gemba walk much more effective and much more productive. Now, from an overall operating system point of view, I've got a typical Hoshin-Conry policy deployment matrix here. And usually these are very static. And if you don't do policy deployment, you do MBOs or OKRs or balanced scorecards or just looking at KPIs and so forth. However you do that, very often these things are put together once a quarter, once a year, at best once a month. And maybe your KPIs are updated, every week, every other week, something like that. But you don't have the ability to have people see where they're at with these things in real time. By taking this same process of linking your long-term objectives to this year's objectives, to the short-term initiatives, to the critical metrics to improve and so forth, you can create a digital management operating system for your organization where you can actually tie all of this in one place, so that I not only see how I'm performing at all times in real time, but I can also tie my improvements and the feedback from the organization directly into that system as well, and keep everything in one place, so that I can look to see not only the fact that I had a miss here on my total case incidents in China, but I can also track exactly what was done by the organization to address that. And then I can track that over time to see, are they actually making that better with the improvements that they're making? And I can look at the trends and everything else to see, am I going the right direction? Am I going the wrong direction, and so forth? And fundamentally answer the most important question, which is, am I winning or am I losing? And being able to do that essentially in real time at all times. And so I've worked with a number of different companies, a number of chief operating officers, and this is the question that they always talk to me about in terms of putting analytics in place, different reporting, shop floor metrics, et cetera. They just want to know, just break it down. At this moment, am I winning or am I losing? And what can I do to make it better? And so, those are the fundamental questions that we have to ask. First of all, to get that top level answer, but then to also understand, what are those deviations to the plan that are happening in real time? So how do I get that real-time visibility to, those things that aren't going as expected? I have a machine down, I have somebody that didn't show up for work today or went home sick. I've got supplier delivery that I thought was going to come here that didn't. And so now I need to be able to kind of replan my, factory so that I can figure out what I can make and, put those things in place and so forth. Tying my, Kanban execution into these different things and so forth, so that I can replenish those Kanbans, from the suppliers as needed and so on. And so being able to have that real-time visibility in combination with, knowing at a high level whether I'm winning or losing, helps to really create that execution piece of that digital management operating system. So now I'm going to switch to some of the different tools that we have within the Lean framework. And one of those is setups and SMED, and being able to look at how we do those setup reductions and so forth. And part of that we can look at task tracking. So to understand why I have setups of the length that I do, and how I'm seeing so much variability. Sometimes it's 1 hour, sometimes it's 3 hours, and so forth. What I can do is I can actually start to do task tracking, whether it's with RFID chips or whether it's with video analysis. There are very sophisticated tools out there these days in order to break down the different steps that are happening within setups, and to do that on a fairly automated basis, so that you can see, are the different people doing setups the same way? How does it get impacted when you go from product A to product B versus product B to product C versus product C to product A? And so I can automate a lot of that process and do a lot of that comparative analysis, much more automated than I could before. I can provide visibility for advanced kitting and so forth, so that I have a really good idea of what's coming next, where I stand, and have that real-time visibility so that I can get the coordination of the different people within the organizations required to get those setup kits ready and delivered to the equipment exactly when they're going to be needed. And then finally, the documentation and delivery of the standard work around setups, and then being able to detect those deviations from that standard work as well. When we're going about fixing a lot of short stops, or fixing a lot of different quality issues and so forth, error proofing is very often what we need to put in place. And when we look at things like augmented reality and being able to do what we're doing here and highlighting the different pick bins for the current SKU that's in front of me, and being able to detect if my hand goes into the wrong bin, these are things that can significantly reduce the amount of errors that I have within manual assembly processes, or pretty much anything, and can be applied very broadly to any kind of error proofing that I want to do. From a total productive maintenance, keeping equipment running perspective, when I look at something like autonomous maintenance and being able to support operators as they perform those practices, rather than just kind of pushing things down to the operator and saying, well, you're in charge now, you run the equipment every day, so you keep it running. If we can tell them, here's exactly what is on your list for today, for what should be done, and here are the work instructions for that. And we know those things because we're able to track all of the performance metrics for the machine, be able to track when different activities are happening, how long they should take until the next time that task should be performed, having the instructions and everything else to go along with that, whether that's just on a computer screen or whether that's through those AR devices and so forth. We can make that autonomous maintenance practice not only significantly more effective, but much easier for our people as well. And then the same thing for preventive maintenance with our maintenance staff. Condition-based maintenance is obviously something where if I'm putting an IoT system in place and tracking those detailed metrics from the machine, I can do a lot more around condition-based as opposed to just set intervals for preventive. And predictive takes that to that next step to keep the machine running even longer between failures. And then looking at other processes to support that with Kaizen and failure modes and effects analysis. And I'll talk about those in more detail in a minute. Value stream mapping. I don't want to steal the thunder too much because next week I'm doing a half-hour session on how to automate value stream mapping. But essentially, if I have all of this information in the system about what products are being made on what machines at what time, how long it's taking, I have RFID tags tracking material flow throughout my facility. I've got all the information I really need to create a value stream map. I can see what are those value add activities. I can see the non-value add activities, how long it's taking between steps and so forth. I can not only see what the average time is, but the entire distribution of times as well, so that I can see what are the extreme values. I can see the good and the bad. I can track deviations to that. So instead of only looking at the path that things are supposed to take, I can look at all of the paths that product family takes to go through manufacturing and so forth. And so there's a ton of advantages to automating that process. FMEAs, likewise. So as I go through, I do an FMEA process, usually a very valuable process, but then it usually goes and sits in a drawer someplace, or on a file on a computer. And very often it doesn't get looked at very much again. But once I create an FMEA that's digital and connected to my IoT program on the shop floor, I can actually have that be a live system that I'm tracking things against, so that I can identify when I have failure on the shop floor, I can identify what is the failure mode that's actually attached to, and automate the process of updating my probability of occurrence, probability of detection, my severity, with that additional information that I'm collecting. And then I can keep up to date on, am I detecting additional failure modes that I didn't have within my FMEA and so forth. And so I can keep this an evergreen document that I'm using to help manage my efficiency and my quality within my operations. Kaizen process. If I look at a 6-step typical Kaizen process here, technology and data can help with each and every single one of these. I did a recent webinar on the Kaizens, and so I'm not going to go into too much detail here, but every single one can be significantly enhanced through having that additional data available. And you can make your Kaizens really, really more effective as you go through that process with the help of all of that additional data. Same thing with root cause analysis. This one I typically don't get a whole lot of pushback on, because data is great for doing root cause analysis. Just it makes it work. So with all of that about the data, where do we actually get all of that data? So if we look at what data should be gathered in the first place, kind of the first question I need to ask is, where within the facility should we be gathering the data? What should we prioritize? And you can't install IoT devices on everything at once and just bring everything up and running. It would be great if that was the case, but if you've got any scale to your facility at all, you probably need to prioritize, where do I go first before you connect everything? And so if you have processes that are out of control, if you have critical processes, whether it's from a quality perspective or from a, hey, this is my constraining machine, obviously those are the places that you should go to first. But once you've identified where, then you can tie this back into your FMEA. So if you've done a process FMEA, and what are the different failure modes that you want to be able to detect, guess what? Collect data about those different characteristics that are going to help you make that automatic identification and so forth. Then you need to put plans in place to collect and analyze that data, but also put control plans in place to monitor that data feed, to make sure that you're getting quality data from those different sensors and people that are involved with that process. If I look at when to gather data, it's kind of the same as the old question, when is the best time to plant a tree? The best time to plant a tree is 20 years ago, so that it's fully grown now and providing shade. The second best time is right now. And it's the same thing with data. The best time to start collecting data is years ago, so that you have all of that history about the process that you can already use to analyze and improve it. The second best time is right now, because that gets you to that point where you have an adequate amount of history to do that analysis and improvement. So you need to put a plan in place for data collection and also for the data hygiene that I talked about earlier. So where does the data actually come from? Well, certainly from the devices and sensors that you have out on the shop floor already. You can connect to those and collect readings and diagnostics and lots of other information to kind of fill this big data store that you can collect, whether you're putting that into a historian like OSI Pi, or whether you're putting that into just a regular database, or however you're storing that information. Having that rich data store is going to be what enables all of these other things that we've talked about so far. But then you can contextualize that information coming from the shop floor in a lot of different ways. So being able to connect to MES system or an ERP system and so forth is going to allow you to dollarize that data that you're collecting from the shop floor, so that I know that downtime on this machine doesn't cost me the same as downtime over here, whether it's the number of operators that I'm causing to be idle, the number of people that are involved in making those different repairs and so forth. Doesn't a meeting cost me more than an electrical failure on the machine and so forth? And how do I record that difference and so on, so that I can see that real-time deviation from my cost perspective? And being able to get all of that information and being able to tie in warranty data and so forth to the analysis of what's happening on the shop floor, so that I can track not only where I'm creating quality defects within the plant, but where I may be creating quality defects that don't show up for another 12 months as that product has been in the field and so forth. And so being able to collect that data not only from the shop floor, but then tie that into all that extra context and do that very rich analysis will show you things that otherwise you would not see. From a performance metrics and how you're displaying this data, you should tie this into the different processes that you have in place for continuous improvement. Whether that's TPM, total productive maintenance, doing Six Sigma analysis, total quality management, some of the standard lean tools that we've talked about, OEE analysis and so forth. All of those things, you have people that are invested in those processes within your company. So think through how you take this data and enrich each and every single one of those processes, so that what people are already doing in their daily operation can be enhanced with this additional level of detail. Just some closing thoughts here. We have a typical roadmap that we work through with our customers, and then we have workshops that are available as well for anybody that would be interested. What we look at as the typical path to success is to begin with the end in mind, map out the vision up front, start with a value. How are we actually going to drive improvements to the business? And the way that we do that is not just by putting software in place, but looking at what are the new business capabilities that we're going to put in place that directly address the root causes for the current level of performance. And that's what we mean by mapping out the vision. And once we have that vision in place, how can we get started by utilizing the data collection and other analysis tools and so forth that you already have in place on the shop floor? You already collect a lot of data. It's just a matter of utilizing it more effectively and making it more visible. And then, of course, putting additional systems like an IoT system or something along those lines, in place to fill those capability gaps on the shop floor can also provide a lot of value. And then integrating across processes, and I don't necessarily mean from an IT perspective here, but how do the different groups within your organization work together so that I can put a design for Six Sigma or design for manufacturing process in place. I can look at that warranty information tied back into my manufacturing process to see how does what I do in manufacturing impact what shows up in warranty later and so forth. And so those are the different things that we look at there. But then at every single step along this path, I need to look at the culture and the processes of my organization And what changes do I need to make in order to really, really take advantage of those software capabilities, those hardware capabilities that I'm putting in place? Because again, if I don't do that, it's just like wearing a Fitbit, but not exercising. You're not going to lose the weight. And here, if you don't change those processes and adapt the culture, you still won't see the benefits that you're hoping to. So all of these things can provide a lot of value, but you have to take advantage of them. So with that, I want to thank you. I don't see any questions. And so, please reach out to me at either the phone number or email you see here. And otherwise, I look forward to talking to everybody next week when we dive into automating value stream analysis. Thank you.